Alright, this is one type of instruction that you will see when you're doing the homework that kind of throws people off, and I'm just going to show you kind of how to do it. It's putting things into standard form. First off, standard form looks like this. Ax plus by equals c. Sometimes it's done with capitals, sometimes it's lowercase letters, whatever. But the point is the the x's and the y's are on the same side of the equation. And more than that, what this instruction is telling you to do is to put it in standard form so that a, b, and c are integers, so that all of these three are integers. Also that those integers have no common factors. So if there is any common factor, you divide through the entire equation to get rid of those common factors. And a is greater than or equal to 0. The coefficient on your x must be greater than or equal to 0. So let's just do a couple of examples here. If we're starting out with the equation y equals negative 2x plus 11, first off, putting the variables on the same side of the equation involves adding 2x to both sides. I get 2x plus y equals 11. And already, you can see this is in the correct form. I have an integer here, 2. I have an integer in front of my y, this is a 1. And an integer here, that's 11. So a, b, and c are all integers. There is no common factor there. You can tell there's no common factor. Well, specifically no common factor bigger than 1. Clearly 1 is a common factor. But yeah, no common factor bigger than 1, because 1 is one of the numbers. And a is greater than or equal to 0. So a is the coefficient on my x there. It's 2, which is greater than or equal to 0. So already, just by moving the 2x over to the other side of the equation, this meets all of those requirements. The reason for these requirements really has to do with the fact that standard form is not a unique form. There's a bunch of different ways I could have written this, and it's still in standard form. So if I had multiplied through this by negative 2, negative 2x minus y equals negative 11 is the same equation. It's still in standard form, but it doesn't meet these requirements. So the whole point of these requirements, like I said, is to guarantee that everyone kind of ends up with the same answer. It's one way of doing it. It's not that common of a requirement either. All right, so let's look at this one. Y equals x plus 3. To get my variables on the same side of the equation, I'll subtract x from both sides. It's not the only way I could have done it, but it's the way I'm doing it. Now, let's see. The a, b, and c have no common factors. There's a negative 1 here, a positive 1 here, and a 3 here, so I'm not worried about that. But my leading coefficient, the coefficient on my x term here, is negative, and that's a no-no because it says a needs to be bigger than or equal to 0. So what I'll do is I'll multiply through both sides of the equation by negative 1, giving me x minus y equals negative 3. Now I'll double check here. Let's see. A, b, and c are integers. Yep. There's no common factors. 1, negative 3. Okay, check. And this is bigger than 0. Bigger than or equal to 0. So this is the correct form there. That's the correct form on this one. All right. Moving on to the next one. Let's see. Again, I'm going to subtract. I'm going to move my x term around. So I'll subtract 1/3 x from both sides. I get negative 1/3 x plus y equals 11/3. All right. My three coefficients here are not integers, and that's the first requirement. It says they are integers with no common factors. So what I'm going to do to make them integers, I want to get rid of those denominators. I'm just going to multiply through everything by 3. In general, you would multiply through by your least common denominator. So when I do this, I'll multiply through that side of the equation by 3, and that side of the equation by 3. Let's see, this gives me the opposite of x plus 3y, and equals 11. You can see my leading coefficient is negative, so that's still a problem. So I need to multiply through by negative 1 also. I get x minus 3y equals negative 11. I could have kind of done this in one step if I'd multiplied through by negative 3 as opposed to positive 3. In any case, that's what I get. And then the last one here, I'll start off by adding 1/3 x rather. To both sides, I get 1/3 x plus y equals 10/3, and you can see this is very much like that last one. I'll multiply both sides by 3. I'm doing parentheses here to remind me that I have to distribute. I get x plus 3y equals 10. And you can see that's already in the correct form, so that's my final answer on that one. That's my final answer on that one.